Multiplication of matrix. So what we want to look at, first of all, we want to look at scalar multiplication. When we talk about scalar multiplication, what do we mean? If let A equals to this matrix and K be a scalar, the matrix K dot A or K multiplied by A is called a scalar product of the matrix A and this constant K. So when you multiply a constant by a matrix, what you are doing there is what we call scalar multiplication, and we denote it by dot. So K dot A is called scalar product, of this matrix A and this constant K, which is the same thing as K, the constant, multiply all, by the matrix, the element of the matrix A. And how to do that is to ensure that you use the constant to multiply by each element of the matrix. So K multiplied by the element, you see, this is the element of this matrix, this is the element of this matrix. The constant, we have to effect all of them. You multiply each of the element by each of the constant. All right, so like we have example 1, let X equals matrix S equals to this, and matrix Y equals to this matrix. Find 2S, B minus 3Y, C 4X minus 2Y. Okay, so solution, the first one, 2X, will be equals to 2 or multiplied by matrix A, matrix X. Matrix S is 4 minus 11, 8, and 3. Look at it here. So 2 multiplied by them. So we use this 2 to multiply by each of the elements. That's what we call scalar multiplication. So 2 times 4 is 8. 2 times minus 11 is minus 22. 2 times minus 8 is minus 16. 2 times 3 is 6. So we are done. So 2x will give us this matrix. Also, we have minus 3y. So this is going to be equals to minus 3 into y as the matrix y. So minus 3 times minus 5 will give us plus 15. Minus 3 times 1 will give us minus 3. Minus 3 times 0 is 0. Anything multiplied by 0 is 0. Minus 3 times 6 is minus 18. So this minus 3y will give us this value, this matrix. Also, we have 4x minus 2y. Okay, 4x minus 2y. This is going to be equals to 4 into the value, the matrix x is this. So minus these two, the matrix y is this. So 4 times 4 is 16. 4 times minus 11 is minus 44. 4 times 8 minus 8 is minus 32. 4 times 3 is 12. Then minus down. All right. 2 times minus 5. You are going to leave this minus alone. Okay. Don't use this minus. Very, very important. Don't use it so that you won't get confused. Always bring the minus down. Treat these two as a constant only. 2 times minus 5 is minus 10. 2 times 1 is 2. 2 times 0 is 0. 2 times 6 is 12. So now you can now use the minus now to perform your operation. So what you are going to have is 16 minus 10 is 24, because minus is plus. So 16 plus 10 is 26 rather. 26. So we have minus 4 minus 4 minus 2 is minus 46. Minus 44 minus 2 rather is minus 46. Then minus 32 minus 0 is minus 32. 12 minus 12 will give us 0. So this is what we call scalar multiplication. All right, so matrix multiplication. Now let A equals to matrix A is this, and let matrix B equals to this. The product of matrix A and B, written as A dot A or AB, is a matrix C. They are going to have a new matrix C from their product, which is going to be C11, C12, C21, C22, gotten by multiplying the row of matrix A with the column of B. Yes, to get the multiplication right, the row of matrix A will be multiplied by a column of matrix B. Okay, so then Now let us see how C will be gotten. Now C is equals to C11, C12, C21, C22 from AB or A dot B. So such that our C11, how do we get C11? This C11. To get this C11, you are going to multiply this. Look at what we have here. To get this, you discover that A11 is, follow the arrow, is multiply, A11 is multiplied by B11, A11 multiplied by B11 plus A12 is multiplied by B12. See, plus A12 is multiplied by B12. If you are able to do this, multiply them together, add them together, what is going to give you that single value? If you solve this, the single value is going to give you is your C11, this entry, the first entry. So you are going to do for each like that. So this is how to get C11. If you can perform this operation, you get your C11. Okay, so now how do we get our C12? This point now, the second entry, if you are multiplying two matrices together to get this second entry in this row, how do you do it? How to do it is this. You are going to have A11 times B12, B12 plus A12 times B22. Look at it here. See it here. A11 times B12 plus A12 times B22. Okay, so that is how to do it. So this first one, why are we still using here? Because what we are looking for is still in the first row. So we are using the first row and we are multiplying it with the second column. Why are we using the second column this time around? We are using the second column this time around because you discover that this particular one we want to find is now in the second column. Okay, so first row, second column. So we are using first row and second column. So to get this third entry, 21, C21, you discover that we have moved to the second row but first column. Second row, this one is in second row, first column. So we are going to, from the first matrix, we are going to move to the second row, and then the second matrix is in the first column. So it's going to be A21 times B11 plus A22 times B21. So to get this C21, A21 times B11 plus A22 times B21. All right, so now here, the last one, C22. How do we get C22? C22 is in row 2, but it's in second column. So therefore, we are going to still maintain row 2, but we are going to move to second column in the second matrix. So therefore, you are going to have A21 times B12 plus A22 times B22 will give you this. If you perform that operation, which is the last one here, this one, A21 times B12 plus A22 times B22 will definitely give you this. So note, the matrix AB is defined or fit for multiplication if and only if the number of rows in matrix A is equal to the number of columns of matrix B and vice versa. So it's not every matrix you can multiply together. Before you multiply every matrix together, you have to ensure that the number of the row of one of the matrix has to be equal to the number of column of the second matrix. Here we have one row, two row, here we have one column, two column. So the number, we have two row here and we have two column here, so they can go together. We'll look at example. Look at this example. Given that A is equals to this matrix, this is 3 by 2 matrix. 3 by 2 matrix in the sense that I have 3 row, I have 2 columns. So it's 3 by 2 matrix. And this is what we call 2 by 3 matrix. 2 by 3 matrix is because it has 2 row and it has 3 column. So it's 2 by 3 matrix. Is this matrix multipliable? Can we multiply it? Yes. Why? Because the number of the row of matrix A is the same thing with the number of column of matrix A. How many rows did matrix A have? It has 1, 2 row, 3 row. How many column did matrix B have? 1 column, 2 column, 3 column. So 3 row, 3 column, 3 row, 3 column. So therefore, they can be multiplied. So find AB, BA, and then the last one is AB equals to BA. AB equals to BA. So we'll find out. So solution, let's find our AB. A multiplied by B. This is matrix A. This is matrix B. So if you are multiplying these two matrices together, you discover that we are going to follow the rules that we use. So you see, the rule of this first matrix will be used to multiply with the column of this second matrix. So let's go. This is 2 times 4 plus 3 times 5. That is what we have here. 2 times 4 plus 3 times 5. Okay. So the next we have gotten to give us this first entry. Alright. So to get the second entry, 2 times 3 plus 3 times 1. How do we get this one? We go again to the first row. 2 times 3, then plus 3 times 1. Give us this. So the last one is going to be this. It's just like opening your bracket. You use this to multiply this. You use this to multiply the middle one. You use this to multiply the last one. It will give you the first row of the new matrix. You have to use this one now. Use this to multiply by each column. This, it will give you the second row. You use this last one to multiply by this, by this, by this. It will give you the last row. So we are done with the first one. The second one is 4. To be 4 times 4 plus 1 times 5. So 4 times 4 plus 1 times 5 here. Then 4 times 3 plus 1 times 1. 4 times 3 plus 1 times 1. Alright, so the next one is 4 times minus 2 plus 1 times 4. Okay, so 4 times minus 2 plus 1 times 4. Then we go to 5. 5 times 4 plus minus 1 times 5. This is what we have here. Okay, so 5 again times 3 plus minus 1 times 1 is what we have here. 5 times 3 plus minus 1 times 1. Then 5 times minus 2 times plus minus 1 times 4. 5 times minus 2 plus minus 1 times 4 is what we have here. So this is how to get this. If you can be able to get this, the other one algebraic process. So now we have 2 times 4. 2 times 4 is 8. Then 3 times 5 is 15. Alright, so 2 times 3 is 6. 3 times 1 is 3. 2 times minus 2 is minus 4. Plus 3 times 4 is 12. 4 times 4 is 16. Plus 1 times 5 is 5. 4 times 3 is 12. Plus 1 times 1 is 1. 4 times minus 2 is minus 8. Plus 1 times 4 is 4. 5 times 4 is 20. Plus minus 1 times 5 is minus 5. Alright, so here 5 times 3 is 15, plus minus 1 times minus 1 is minus 1 times 1 is minus 1. 5 times minus 2 is minus 10. Then plus minus 1 times 4 is minus 4. Then 8 plus 15 is 23. 6 plus 3 is 9. Minus 4 plus 12 is 8. 16 plus 5 is 21. 12 plus 1 is 13. Minus 8 plus 4 is minus 4. 20 plus minus 5 is 15. 15 plus minus 1 is 14. Minus 10 plus minus 4 is minus 14. So if you multiply A, B, you will get this matrix. This is a 3 by 3 matrix. Alright, so the next one is BA. We want to find BA. Now, BA is turning B comes first, then A comes later. Alright, are they multipliable? Yes. The number of the row here is 2. The number of the column here is 2. So 2 row, 2 column, 2 row, and 2 column. So they are multipliable. So let's go. This is 4. 4 times, this is going to be 4 times 2 plus 3 times 4 plus minus 2 times 5. This is what we have. 4 times 2 plus 3 times 4 plus minus 2 times 5. This first entry. We use this again for this. We have to use this for this. Then we go to the second one. We use 5, 1, and 4 for the first one. Also use 5, 1, and 4 for the second one. Just like you open your bracket. So 4 times 3 plus 3 times 1 plus minus 2 times minus 1. That's what we have here. 4 times 3 plus 3 times 1 plus minus 2 times minus 1 will give us this entry. You discover that we are done with the first row. So this is the first row. We are done with this first row. So we move to the second row now. Second row will give us the entry on the second row. So second row, 5 times 2 plus 1 times 4 plus 4 times 5. 5 times 2 plus 1 times 4 plus 4 times 5. That is what we have here. Then 5 times 3 plus 1 times 2 plus 4 times minus 1. That is what will give us this entry. 5 times 3 plus 1 times 1 plus 4 times minus 1. Then we have to multiply them out. Now you discover that 4 times 2 is 8. 3 times 4 is 12. Plus minus 2 times 5 is minus 10. Then 4 times 3 is 12. 3 times 1 is 3. Minus 2 times minus 1 is going to give us plus 2. Then we have 5 times 2, 10, plus 1 times 4 is 4, plus 5 times 5 is 20. Then 5 times 3 is 15. 1 times 1 is 1. Then 4 times minus 1 is minus 4. So 8 plus 2, 8 plus 12 minus 10 will give us 10. Then 12 plus 3 plus 2 will give us 17. 10 plus 4 plus 20 will give us 34. 5 plus 1 plus minus 4 is going to give us 12. So you discover that the value we got A for BA is 10, 17, 32, 12. But the value we got for AB is this. So they are not the same. So the third question says, is AB equals to BA? No. AB is not equals to BA. Note, in general, matrix multiplication is not commutative. Yes, matrix multiplication is not commutative. Very, very important. Alright, example 4. Let A equals to this matrix and B equals to this matrix. C is equals to this matrix. So is A, open bracket, B plus C, close bracket, equals to AB plus AC. Is AB in a bracket multiplied by C equals to matrix A in a bracket multiplied by BC. close bracket. So this is a question. We want to prove whether the left hand side is equal to the right hand side and the right hand side is equal to the left hand side. Alright, so solution. First of all, this first one, we need to find the left hand side, this side first, then we'll later find the right hand side to know whether they are equal to themselves. Alright, then so A open bracket B plus C close bracket is the same thing as is matrix A open bracket matrix B plus matrix C, and close the bracket with the major one. So this is going to be equals to matrix A is here to multiply. We add this together. 5 plus 3 give us this 8. 0 plus 3 give us this 3. 6 plus 2 give us 8. 1 plus minus 1 give us 0. Alright, so then we have to multiply this out. If you multiply this out, what you're going to have is 1 times 8 plus 4 times 8. That's what we have here. Then 1 times 3 plus 4 times 0 is what we have here. Then 2 times 8 plus minus 3 times 8. This is what we have here. Then 2 times 3 plus minus 3 times 0 is what we have here. So 1 times 8 will give us 8. 4 times plus 4 times 8 will give us 32. 1 times 3 give us 3. Then plus 1, 4 times 0 give us 0. The same thing happen here. If you multiply this and then you get this. Then if you work with this, you'll be able to get this. 8 plus this. 8 plus 32 give us 40. 3 plus 0 give us 3. So by the time you do the same thing here, 16 plus minus 24 is minus 8. 6 plus 0 is 6. Okay, so we have gotten the left hand side, this first one. That's the left hand side, which is 43 minus 8 and 6. Okay, so let's get the right hand side now. The right hand side is AB plus AC. So let's get it now. AB plus AC is equals to, this is matrix A, matrix B plus matrix A and matrix C. Alright, so we multiply this and this together. 1 times 5 plus 4 times 6 is what we have here. Then 1 times 0 plus 4 times 1 is what we have here. Then 2 times 5 plus minus 3 times 6 is what we have here. Then 2 times 0 plus minus 3 times 1 is what we have here. Plus the same thing goes with this. You can pause the video to see how, try this multiplication out, how we get this. Look at it very well. If you don't understand how this is gotten, you can forward the video back to how I got this to be able to find it out yourself. Alright, so by the time you multiply this out, 1 times 5 is 5 plus 4 times 6 is 24. The same thing happened with this operation to get this. The same operation here, we got this. Alright, the same operation here, we got this. Then the same thing happened here too. 1 times 3 is 3 plus 4 times 2 is 8. 2 times 3 is 6. That is what we did to get this place. Also what we did here, 1 times 3 is 3 plus 4 times minus 1 is minus 4. Alright, so by the time you add this, 5 times 24, 5 plus 24, 5 plus 24 will give us 5 plus 24 will give us 29. Alright, so 0 plus 4 will give us 4. 10 plus minus 18 will give us minus 8. 0 plus minus 3 will give us minus 3. So the same thing here, 3 plus 8 will give us 11. 3 plus minus 4 give us minus 1. 6 plus minus 6 give us 0. And then 6 plus 3 will give us 9. Alright, add all of this together, and 29 plus 11 give us 40. 4 plus minus 1 give us 3. Minus 8 plus 0 give us minus 8. Minus 3 plus 9 give us 6. So you have 43 minus 8 and 6. You discover that it is the same thing with what we have here. So the left hand side is equal to the right hand side. So A into bracket of B plus C is equals to A. Is it equals to AB plus AC? That is the question, and the answer is yes. It's equals to. So II is for your practice. Share with me what you find out. Okay. So this II here is a open bracket AB close bracket C equals to A open bracket BC close bracket, and then equals to. So find it out. By the time you find it out, you can let me know on my WhatsApp platform or comment under this video.